database. Oh my goodness. Susan Vanderford is a database architect with a degree in computer science and 2 decades of hands-on experience designing and managing databases across multiple industries. She worked in retail, shipping, medical devices, and for the past 10 years has specialized in data systems for the medical insurance field. When she's not neck deep in the schemas and storage engines, Susan enjoys reading, gaming, and knitting and crocheting. Though she claims her crafting skills are still at work in progress, she brings a sharp eye for structure, a love for clean design, and a practical mindset to every project she tackles. So thank you. Welcome.
Okay, those of you in the back, I'm not used to projecting. So if I get too soft, like, wave me down. All right. That's not right. Hey, Chris. How do I make this show different things?
You have to extend the desktop. Right now, I assume you see exactly what's up there, right?
Yep. Sorry, guys. Technical difficulties. That's too cool, cool, cool.
After you're done, I'm gonna have to change this shared settings on Zoom, so it shares just the presentation.
Yeah, I don't have this memorized. I need my notes.
You're welcome.
All right, so we're going to talk about choosing the right database for your project. My contact information is right here if you want it. That's the webpage of the consulting company I work for. That's my LinkedIn. That's my email. It's my name. All right. So about Simply Data, which is the consulting company that I work for, we've been serving businesses since 2016. We specialize in building custom data solutions that are scalable and sustainable. We're going to use the in-house technologies you already have so you don't have to buy new things. We deliver solutions that adhere to your organization's compliance and regulatory requirements. Auditors love our work. We've worked in a bunch of different industries. We deliver our solutions on time and on budget. The main office is based in Wheaton. We have an office here because I'm here. And we're registered and certified by the U.S. Defense Logistics Agency to work with U.S. government entities. All right, so let's get into it. So before we get started, a little bit of a disclaimer. There are some things on these slides that are specifically there because they're geeky and they made me laugh. Be warned. All right, so what to understand about your project before you make a decision. You need to understand your project's requirements. You need to consider your data modeling. You need to evaluate your scalability needs. Are you going to need to scale up really quickly because you're growing really fast? Or can you take your time to scale up and choose maybe a less expensive option? Is performance, how is it going to matter? If you don't have a large data set, like the last company I worked for, they had a very small data set and a very small employee group. They didn't need the highest level of stuff because they had like 20 employees. So we could kind of scrimp on that side when we were building their data warehouse. What's your availability and reliability? Or, can you afford a 10-minute loss of data? Is your data changing fast enough that 10 minutes is a big deal? Or do you need backups instantaneously? Community and support. Different databases have different communities around. So for instance, SQL Server does SQL Server Saturdays all over the US. It's free training. But Oracle, not great at community or training. You kind of have to figure that out by yourself. So different databases have different infrastructures for support and learning. What is the cost and licensing? And what is the flexibility for future growth? Wrong button. All right. This is very important. This is 3 rules. I want to use Excel as a database. There are 4 rules. Excel is not a database. Never say to your data person, I have an Excel database, because that makes them stabby. I do not recommend. 0 stars. All right. So real quick, this is probably not new, but there are 3 ways for a database to exist. It's on cloud, on-prem, and hybrid. Is everybody kind of familiar with these things? Yes. Okay, cool. I'm not going to dive into it then. All right. So one of the types of databases we're going to talk about is a NoSQL database, not only SQL. So what is it? It's going to store queries and data stores outside of the traditional structure of a relational database. Examples of use are going to be fraud detection, identity authentication, medical records, financial services and payments, and cost management. My t-shirt right now says 3 SQL queries walked into a bar. Some minutes later, they walked out because they couldn't get a table. No tables. So the benefits are there are flexible schemas. You kind of can, depending on the database you choose, there's a lot of flexibility. You can kind of do anything you want. It's great at horizontal scaling, high performance, great availability. It's easy for developers. Some NoSQL databases map their data structures to those popular programming languages, and we'll cover a couple of those. Drawbacks are they don't use SQL. There's not a lot of standardization. They don't use joins, which is a way to join tables together to get data, because everything's kind of all over the place. They don't use joins. And it lacks ACID transactions, which is a database concept. It's automaticity. I never say that right. Consistency, isolation, and durability. That's one of them is automaticity. I can never say it. Atomicity. It means that everything is run in order. If one of your jobs or one of your orders in a package fails, it rolls back. And you don't, none of it runs. Your consistency is if you've got multiple things running, and the same with isolation, multiple things running, it's going to run them in order. Nothing's going to overwrite each other. First thing goes first, second thing goes second, and durability. So that's kind of this deep cut in database. But NoSQL types of databases, we're going to cover a couple of them. Document databases, NoSQL data stores, store data as structured documents. They're typically JSON or XML files. They offer flexibility and scalability for applications for evolving data schemas. Some examples of that are Amazon Document DB, MongoDB, CouchDB, Azure Cosmos DB, and Amazon DynamoDB. There's a lot more. Some of these you're going to see on multiple slides, like Azure Cosmos DB does a couple different things. And depending on how you install it, it could be like a graphing database or it could be a document database. Graph databases surprisingly look a lot like that. Oh, let's go back, I'm sorry. All right, so a graphing database contains nodes, edges, and properties that come together to allow users to represent stored data. So basically, a node is a set of data, and the edge is the relationship between that data. As an example, it's used in social media. So if we pick on Chris, Chris is our node. He may have a relationship with living in Cape Coral. The relationship is going to be your edge. Chris is the node. And the object is going to be his location, Cape Coral. Does that make sense? Good? Okay. Relationships are treated with the same importance as the data itself, enabling efficient transversals and querying of connected data. So you're going to see that in social networks. You're going to see it in fraud detection, recommendation engines, knowledge graphs. The big recommendation engines tend to be vector databases. We'll go into those. But some of the smaller ones definitely can be a graph database. Benefits are schema flexibility. The nodes and relationships have different properties without a rigid schema. So if we pick on Chris again, he may have a relational status of married, and he may have kids that have a relationship with him, Sarah and David. But somebody else may not have kids. They may not have that product. They may not have that connection. So it allows you to be flexible within the data sets. Drawbacks, there is a learning curve. It requires understanding of graph theory and query languages like Cypher and Gremlin, which are not common. Fewer mature tools. It's newer and less standardized. Limited analytics support, not strong at aggregation, and heavy queries. Some examples of that would be, again, Azure Cosmos DB, dgraph, Amazon Neptune, Stardog, Neo4j. And by the way, if you have questions, throw them out as we go. All right. Next up is columnar databases. There's the joke. Columnar databases store data in columns instead of rows. So most databases, most relational databases store data in rows, and these store them in columns. The relationships are treated with the same importance as the data itself, and it allows you to transferal and querying of connected data. Examples of use are analytics and reporting, big data processing, real-time analytics. It can be used for machine learning and AI workflows, but mostly it's used for analytics. It's faster on analytic queries. It's efficient in compression. It's great at scalability, and it's optimized for read-heavy workloads. It's not great at writes. So if you're doing a transitional database for, let's say, Publix, when they scan all your food, this is not going to be fast. This is going to be rough. It's slower at low row level access, and it's got complex writes. So the writes are usually done in batches instead of as they come in. So it can be a little bit of a delay. Examples of that are, and here's where we see my geek side, Druid, Snowflake, MonetDB, Speaking personal opinion, I would go with a document database instead of this. Did it stop recording?
Yeah, I messed up. Well, it didn't stop recording, it's still recording, but the screen is no longer sharing. Or not the cable, but the internet.
I'll let you do it. So on this, I would probably go with a document database because document databases work with the same key value pair, similar to an XML document where you've got a tag and then the value, but it allows you to nest them and put as many in as you want, as opposed to this, which is just one key value pair at a time. Great for Internet of Things because you're looking at a small data set, but generally I would do a document database. Again, personal opinion. All right. Some examples are Amazon DynamoDB, Oracle Berkeley DB, Oracle NoSQL database, Redis, and a project Vornamart. I'm not going to lie, that one doesn't even exist anymore. This is never coming off the slide though. It got sunsetted. LinkedIn actually created it, and they replaced it with, I think, an Oracle product. I think Redis. But this will be on there forever. I'm never taking it off. All right. Next up, we're looking at object-oriented databases. Are there any object-oriented programmers in here? This is going to be your favorite. So it's based off the concept of object-oriented programming. So it combines your object-oriented programming concepts with relational database principles. It's most valuable to applications with complex data relationships. Examples of use are CAD, gaming applications, specifically like your character has armor or your character has weapons. That would often be in something like this because you change your armor, you change your weapons, etc. Analytics. Benefits are it's easy to save and retrieve data quickly. It's seamless integration for object-oriented programming languages, which is why you love it. It's easier to model the advanced real-world problems, and it's extensible with custom data types. The drawbacks are familiarity. Your DBAs are not familiar with it. No universal data model. It doesn't support views. Views are where you take tables that are very common, you connect them together with a query, and you create a view that people can query off of instead of querying the direct tables. It's great for reporting or analytics. That's very common in relational databases. Its high complexity causes performance issues. And one of the other problems is, especially with the various data types, it doesn't always transfer to other databases well because of the custom data types. But if you're object-oriented, it's easier. Some examples of those are IBM DB2, Object Store, Wakanda. It's on there. If they ever close, it'll stay on there. Gemstone and ObjectDB. All right. Now we're going into hierarchical databases. They have a tree-like structure with each record or data element being linked to one or more other records or data elements. Examples of that are organizational hierarchy, like your HR has, the company and who works where and who they report to. File systems, product categories. It's fast and efficient data retrieval. It's easy to add and delete information. Don't delete information. Just turn it off. Put a little thing on it, says active indicator, say no, and then insert. This is your DBA giving you information. Don't delete data. It makes us sad. Predictable data structure, efficient storage of data, and good performance, especially for large data sets. The drawbacks are limited flexibility. It's not well suited for handling complex relationships or changes in data structure. It's difficult to maintain and update. It's got limited support for data manipulation, limited interoperability. In other words, it doesn't play well with other database models, and lack of standardization. All right, here's 3 examples. You got IBM IMS, you've got XML data storage and window registry. Next up is time series databases. It's optimized for fast data ingestion and efficient storage for querying time-based data. Examples, again, are Internet of Things, stock prices, energy consumption, sensor readings, equipment stress levels. It's great because it has timestamp data storage. Scalability is great. It does great with volume. It's accurate on time-based information. Drawbacks are it's difficult to set up and maintain, fewer time series databases to pick from, and time series analysis provides a probability value on potential future outcomes rather than actual projected value. All right. And we see Druid again. Prometheus, Timescale, Warp 10, InfluxDB, QuestDB. These are all time series databases. All right, now we get to relational databases, and this is where I've spent 20 years. So I know this one really well. You're looking at, again, at a tree-like structure. With relational databases, you're looking at holding data in tables. It's very fixed, and it is easier to find people to do this work. Sorry, my slide did not switch over. So we're going to do this from memory because I know this one. So relational databases hold the data in a series of tables. You can join them together. There isn't a lot of duplication. You try to keep everything in one period. It's called normalization. You want to keep it at a level 3 normalization so you're not duplicating data in multiple places. And then you're unable to, like, if you make a change in one place, it doesn't transfer over. In relational databases, it's held in one place. So that change then populates out through the different views. So it's easy to see. Relational databases are great at row-based transactions. There are many of them that are excellent at like point of sale. So again, you go to Publix, you scan your food, and each line is written to a row-based database for that purchase. They're also pretty popular in healthcare, shipping. So these are used all over the place. The drawbacks are, the easy part is you can find somebody to work them. They're very common. They are easy to scale up, and they are easy to maintain and keep your I don't know where it's going that. Anyway, they're easy to work with, and you will be able to find people to work with it. The drawbacks are you don't have a lot of flexibility in the schema. There aren't a lot of options for creating your own types of data. You kind of have to stick with what they have. All right, some examples of this are SQL Server, MySQL, Snowflake again, Oracle, Postgres, MariaDB. That is definitely the most common one. All right, vector databases. Vector databases are good for storing, indexing, and querying what they call vector embeddings. Highly dimensional numeric representations of data such as text, images, audio, or video. Examples of use are AI and machine learning, recommendation systems, generative AD or AI. A good example of one of these would be Amazon. When you buy something from Amazon and you put it in your cart and you buy it, suddenly they have all these recommendations based off what you bought. So if you bought a Learning SQL Server book, and then suddenly they give you 1 million Learning SQL Server, Learning SQL the language, Learning Oracle, that's based off a vector database. So what happens is when you put it in the cart and you buy it, the database re-vectors it, processes everything, all of the pieces, and says, based on what you just bought, a bunch of other people bought these same things. We're going to show them to you. And especially with Amazon, they'll also look at, you have also bought these other things. So I can take what you've bought and narrow it down further. to really offer you things that we can then force you to buy more things and get more money. So benefits are semantic search. It finds similar items based on meaning, not exact keywords. Scalability, multimodal search, real-time recommendations. The drawbacks are it's expensive for storage because your storage is constantly growing. It's difficult to maintain and update. It has limited use case. It doesn't do well with transactional data in the sense of like, just scanning it in and holding that. And relational data and the latency. Some searches can induce trade-offs between speed and accuracy. The biggest part is it's expensive to run because it's refactoring your database every time something comes in. And especially if you're in the cloud and you're based on your CPU usage, that's expensive. So there's trade-offs. Some examples of these are Milvus, Pinecone, Vespa, Chroma. This is a Fasis, which is Facebook AI, and Elastic. All right. We did this pretty fast. We've explored different types of databases, and we've covered each service and unique purpose. As databases continue to grow in volume and variety, understanding the type of database fits the problem isn't just helpful, it's essential, and choosing the right tool can mean the difference between scalable system and one that falls under pressure. Also, Excel is not a database. I'm just going to say it again. Does anybody have any questions? Go for it.
So Excel is not a database. Does that mean Access is not a database either?
Technically, Access is a database. But it's not a very good one. That said, 10 years ago, when you flew a United flight and you were they came down that aisle with that cart with the buy on board, all of that provisioning was done with 20 daisy chained access databases. I know because I got hired to fix that. So anywhere you flew on a United flight in the United States, those carts were provisioned by 20 access databases, and they ended up replacing it with Oracle. So technically it is, but if you say that to a DBA, they're going to get sad. Any other questions? Go for it.
I mean, I don't know exactly if it's because I know Oracle has a lot of things, but we use it at work for some third-party things, and it seems to be very slow. Like it's very slow. It seems to be very expensive. Why would people go for it?
What are they using?
Oracle.
Okay. So here's the thing about Oracle, and we're in a relational, so I know this. Oracle is excellent at row-based transactions. So again, you're looking at, you go to Target and they scan all your stuff and it writes to a database, and each line is a table and a line, blah, blah, blah. It's great at that. It is optimized for that purpose. It is not great at aggregation. So if you're looking at market basket analysis to see when people buy this bottle of water, what else do they buy? Is not great at that. You'd be better off moving your data into like SQL Server, which is actually designed for group-based transactions. It is not great at individual, like line by line. So that is probably more of an Oracle isn't great at that. Also, Oracle is super expensive. SQL is less expensive. Go for it.
Something you talk about social media sites and stuff. So like when it comes to like, let's say like Twitter or X, what type of database do you think you're using?
My guess would be graphical, because they're tying together, they're keeping track of your tweets, but they're also trying to show you things that might interest you as well based on your tweets. Especially with the tags. The tags are a great way to kind of tie things together. And Instagram does the same thing. Like, I don't know that they're using a graphical one, but I would assume they are.
You would think that most of the social media sites you see them tying any other database in with that, or no?
So what I would do if I were them is I'd hold the graphical database to hold the relationships between the different tweets and everything. And then I take all that data and I put it in a relational database and I aggregate it, or a columnar database. And I do all kinds of analytics on how I can sell you things based on what you're talking about. I know that that's maybe not as honorable as I'd like, but that's what I do.
I mean, it's reality of owning a digital asset like that.
Because that's where they're making their money, is off the advertising. So yeah. They're also probably keeping track of how many times you click on an ad so they can offer you similar ads. And again, I would run that on like SQL Server or a columnar database where I can do analytics really fast. Any other questions? What you got?
So you mentioned a social media site that's blending multiple different database types.
Mm-hmm.
What is the function and how do you blend these databases?
What is the function and how do you blend them?
Yeah, so I'm familiar with, okay, I'm going to write a function that's going to access my database and give me a result back. How do I make sure that I can access all these different blended databases to get the result I'm looking for?
So I'd probably keep the graphical database to hold all of the data. I'd have something that moves the data over to the SQL Server or whatever. And I'd run my analytics off of that, but you're probably shuttling data constantly, or possibly in batches, although they have a lot of money, so probably constantly. You could also hold that data in a vector database, especially for the advertising, and reconfigure every time you click with something, and then again, push that over to a SQL Server or an Oracle or a relational database or a columnar database where you can do the analytics off of it, but you can use the vector database to keep up with the advertising and keeping it real time. What you got?
So you say with, for memory usage, how would you rate high?
Vector is the worst. Again, because every time it's reconfiguring, it's saving that information. Vectors grow very, very quick. Probably the least memory intensive is key value pair. And then it kind of depends. So for instance, a document database could be very simplistic because you've got a key value pair. A document is a really fancy way of saying like a page, basically. And then with a document, they'll put something like, they use them a lot for medical records. So you've been to the doctor for your PCP visit, and then you went to the doctor, and then the next line within the document is you went to the doctor. I went to the doctor because I broke my leg, right? And then I came back and I got the cast on, sawed off. And all of that information is kept in a document database that can grow based on the activity in your database. So if you've got something like a medical record that's constantly growing, that's going to grow quickly. If you've got a population that is pretty healthy, like let's say you're working with 0 to 18-year-olds, not a high volume in medical other than the regular stuff. It's not going to grow as fast. So that's more with relational and document. It's definitely dependent on what the activity level is as to how it grows. And also, how did the database get designed? Because if somebody's not holding a record of everything that happens and they're just overwriting it, your data is not growing. So an example of that would be a reporting database where I'm just grabbing a snapshot of the data, I'm moving it over to a database. It's not really growing a whole lot unless my data source is growing, because I'm not adding new things to it as far as from an auditing standpoint, right? So from a medical record standpoint, you never actually write over a row. You turn it off and you add a new one so you can keep track of everything that happened. But from a reporting standpoint, I may only hold active records because nobody cares about the inactive records, right? So that data set doesn't grow as fast. Kind of depends on how you're using it, basically. Does that answer your question? It's not a quick, easy. The vector is definitely going to use all your storage.
Which one- Yeah, which one?
Vector. Yeah, with a relational, you know it's coming. You can set up all kinds of warnings. Your growth is usually not, it's on a steady incline. You can tell it's coming. Vector, because it's constantly refactoring, that just grows exponentially.
Do you have any strategies for adding indexes?
You don't really have a lot of indexes in vectoring. In
Relational?
relational, you usually know your data well enough to know what you should do a index on. So for instance, if you're doing medical, member number, diagnosis, claim number, those are the things you're going to use a lot of. The information about who you are as a person, like, you know, are you male or female? It doesn't get used as much. I don't need to index that. So it's really knowing your data set as to what you're going to do your indexing on. And you can also watch your queries and see, oh, I'm seeing this querying more often, and you can create a new index. Any other questions? Go for it.
So, for those that don't know, I just did an internship. I was working at a credit union. So I was doing business analytics. I was working a lot of data for that internship. One of the tasks at the end of my internship was that I was basically I had a bunch of dashboards that needed to be optimized. So they were using something in like my company's, it was this credit union. It was something called the model. I'm curious about your perspective on the model, what you would, maybe if it gets classified as one of these. Basically, it was built into Power BI. Their idea was that it would be like all the data they would ever need is imported into Power BI, and it's all connected to each other, all of these tables, and there's just like a bajillion tables. Therefore, like the model, like the dashboards itself, when you would load them, would be super slow because there was a ton of extra data that wasn't necessary.
Yeah.
My goal was to optimize it, to rewrite it, and then remake the dashboards with pulling from like a SQL database. We used a SQL server and pull SQL and rebuild them. So would that model be classified as one of these things you discussed, or is that kind of just they're doing their own thing? I don't know what your thoughts are on that.
So I've worked with Power BI, and you can connect it directly to your database and just connect it directly to tables. I don't generally recommend that. I would create views that I would then create it because you can limit what the view sees. So you're not pulling all that extra data. That's how I would do it, but you can directly connect if you just get everything. So if you're, working for a company that has 30 years of data, you probably don't need 30 years of data for most reporting. You probably need what, like 2 years on general? Maybe 5, probably 2. So I would use a view in that case and then query that. It'll give you a smaller subset of data. And then that would work. Any other questions?
Just follow up the social media question. So,
Yeah.
like with the social media site, especially like in a startup situation, you might go like Google Ads or something like that. So they're basically already doing all of that. They're analyzing your data and stuff like that, and deciding which ads to feed which customers, correct?
Yes. Yeah, they're already doing all that for you, and they're probably also looking at other businesses like yours to give you a bigger data set. So for instance, I just started a new job for my day job, and they sent me through Epic training. I just finished that today. One of the things Epic does is they offer the same concept, which is you can take your numbers, your percentages, and compare them to people in the same industry and see how you're doing across the industry. So if you're looking at pediatrics, let's say your pediatric quality of care is at 79%. What is the industry for pediatrics at? Well, it's at 65%. Oh, we're doing better than the industry. That's great. Google Ads is probably doing the same thing where they're looking at you and what you're doing and what do other people do and pulling that in to get you a better ad choice, if that makes sense.
So it's pretty, like in the television business, you know, you've got like local ads and then we have like national ads and stuff like that. So looking at like, comparing that to like a social media site, I would consider like Google almost like national ads. And let's say you have your own ads on your site, you have like an advertiser package, you're running both maybe for a while. Does that, in your opinion, I don't know if this goes too far off topic, but does that get complicated or no? If you're going outside of, is it better to either run your own ads solid or run Google ads, or is running a combination of your own ads in conjunction with Google ads, is that still a pretty logical thing to do, easy to do? I don't know.
So I'm not familiar with Google Ads as far as how it works.
Right.
I don't know if they do local ads. They'd be silly not to.
No, I guess what I meant was if the site has its own client,
Mm-hmm.
and then you're also trying to, well, let's say you don't have enough clients as a startup to fill out your ad space, or, you know, is that normal to kind of in a social media environment like that, to use Google Ads, then they also have your own ads as well, so you have like almost two different data sets. Does that make sense what the question is?
That makes sense.
Okay.
So I am positive that Facebook, Instagram, all of those are doing the same thing. They've got sections that are dedicated to people who pay them money. Look at how they do sponsored results, right? When you're scrolling through Facebook and they're like, hey, you were really interested in IT memes. Here's another 5 groups that do IT memes. And here's a company that produces IT memes. So yeah, it happens. What you got?
I recently just finished a class. It was data analytics and data. So I worked a bit with Spark, PySpark. Do you know, because I'm still kind of new to databases, accessing data, like how PySpark or a tool like that for accessing a lot of data connect with kind of the variety of database use stuff?
So PySpark can probably interact with pretty much anything. Just like Power BI can interact with Oracle. Like nobody does it, but you can do it.
Yeah.
Microsoft has their own stack. They really want you to use their own stack. Azure has their, or not Azure, AWS has their stack. They really want you to use your stack, but you can get SQL Server on AWS. I don't think you can get Cosmos DB, but you can get a SQL Server. So you can use other tools, and especially if you're not in the cloud necessarily, I think it's easier to use other tools. When you're in Azure environment or AWS environment, in my opinion, I think they deliberately make it difficult to use other tools, so theirs are easier. I don't have proof of that. That is my personal opinion.
There's different ways to access data. Choose one for accessing. What would you recommend, like PySpark 4 maybe? Like general? I don't know if you know.
I don't know that one, unfortunately.
Thank you.
No problem. What you got?
So in your opinion, what are your golden rules when it comes to using composite keys in a relational database?
What are my golden rules when I what?
When you use composite keys in a relational database?
Composite keys in a database. It depends on the data set. I'm going to be honest, I often use composite keys. So as an example, when I was in medical and I was on the insurance side, my stepdad has MS and he has a heart problem. And when we lived in Chicago, he had a very specific doctor who worked with MS patients who have cardiac issues. That's all he did. That doctor worked in 7, I think, hospitals because he was so specialized. So he had an NPI, which is National Provider ID, which is his NPI ID. And then there was a TIN for the location he was at. But not all hospitals accept all insurance. So you had to check his TIN and his NPI together to see if he was covered by the insurance company. And that's where you'd have a composite, for instance, because I need both pieces in order to answer the question.
And use at most 2 columns as the primary.
I'm sorry, I didn't hear you.
That use case only use 2 primary columns.
Right, you can do more. You can also run them into a whole, like, you can use 4 columns and just smash them together and say, this is the unique ID.
If you're designing a great enterprise software, do you ever use 1 to 2 or server mount composite keys?
I mean, theoretically, it's possible. I'm not super familiar with anybody who's done it, but yeah, it's doable.
The question is, what would you recommend?
If you can get down to 1 or 2, use 1 or 2 columns. Try to make your keys as simple as possible. If you've got to use 4, because those 4 pieces of information, for instance, or those 8 pieces of information make it unique, then you got to do that. Data is messy, especially when it involves people. People make things messy. Any other questions? Okay. Well, hold on a sec here. Thank you. And there's my contact information again if you want any other questions. Ta-da.
All right, thank you so much, Susan.
You're welcome. I don't know how to turn off the recording.
That's okay. Ah, shocked me.